Hello everybody, I hope all of you are well. In this video, I'm going to discuss about carbon and nitrogen sequestration. Let's get started. When we talk about climate change, we often think about carbon dioxide in the air. But what if the real solution lies beneath our feet? Beneath every farm field, every forest floor, and every patch of grass, there is a living engine quietly capturing and storing the building blocks of life, carbon and nitrogen. This natural process is called carbon and nitrogen sequestration. The ability of soil to absorb and store these essential elements from decades, even centuries, it's one of the most powerful tools we have for mitigating climate change, improving food security, and restoring degraded lands. Let's talk about what is carbon and nitrogen sequestration. Carbon sequestration occurs when plants absorb carbon dioxide from the atmosphere during photosynthesis and transfer part of that carbon into the soil through their roots. Over time, this carbon becomes part of the soil, organic matter, humus, microbial biomass, and stable organic compounds that lock away carbon for years. On the other hand, nitrogen sequestration involves the capture and stabilization of nitrogen in organic and mineral forms, reducing its loss through leaching or gas emission. Together, carbon and nitrogen form the foundation of soil organic matter, driving fertility, structure, and water retention. Under continuous no tillage with organic amendments for over 25 years, studies have shown that compost and manure treatments significantly increase both soil organic carbon and total nitrogen compared to cover crop and fallow systems. These findings confirm that soil isn't just dirt, it's a living system capable of storing immense amount of carbon and nitrogen when managed correctly. Let's talk about how it works in the soil. When organic residue, compost, or manure are added to the soil, microorganisms begin breaking them down, releasing nutrients and forming humic substances. Part of this carbon becomes labile carbon, easily decomposed, while another fraction becomes recalcitrant carbon, resistant to decomposition and crucial for long-term sequestration. Similarly, nitrogen becomes incorporated into microbial biomass, humus, and clay organic complexes, forming a stable reserve. Over time, the balance between decomposition and stabilization determines the net gain in soil organic matter. This delicate balance depends on management practices, soil type, moisture, and temperature, all interacting within what scientists call the soil carbon nitrogen cycle. Let's talk about why it matters for climate and food security. Every ton of carbon stored in soil means less carbon dioxide in the atmosphere. Healthy soils are hold more water, resist erosion, and provide crops with a slow, steady supply of nutrient. This improves food production while reducing the need of synthetic fertilizers, a win for both farmers and the environment. Globally, if we could increase soil organic carbon by just 0.4% per year, an initiative known as 4 per 1000, we could offset a large portion of annual greenhouse gas emissions. That's the power of soil. Now let's talk about the bigger vision. My research, as part of the Ohio State University's long-term no-tillage program, focuses on understanding how organic inputs influence carbon and nitrogen dynamics across depths and years. Through careful sampling, analysis, and modeling, we are learning how compost, manure, and cover crops under no-till systems can rebuild soil carbon and nitrogen pools, improving both productivity and sustainability. This work builds on decades of research from scientists like Dr. Lal and many others who have shown that restoring soil health is key to achieving global climate goals. Because when you care for the soil cares for us. Soil is more than a medium for plant growth. It's Earth's largest natural carbon bank. Every drop of organic matter, every microbial breath, every root that decomposes contributes to the silent work of sequestration. If we protect our soils, we protect our planet. Let's manage the land not just for the next harvest, but for the next generation. Thank you so much for watching this video.